Hey everyone, welcome back to another episode of the LlamaIndex webinar series. Today we're really excited to feature PrivateGPT, which is the leading RAG project, privacy-aware RAG project, and they got a ton of popularity on GitHub a few months ago. I think you're sitting at around like 44,000 stars or something, and so just a lot of interest in kind of building one production grade RAG and two with local models so that you don't actually make external API calls. And today I'm thrilled to have the team join to basically talk about one, the kind of like origin story, two, basically a little bit about how it works as well as some of the use cases. And of course, we'll have the section for Q&A as well. And so with that said, Daniel and Ivan, feel free to take it away.
Sure. Well, I'm going to take the lead. Ivan will join later. Let me then share my screen and let me know if all of you can see it, I guess, right? Cool. So thank you, Gary. Thank you, everyone. Thank you to the Llama folks and for everyone to be here today. It's really a pleasure for us to be here. We started this like a few months ago, which seems like an eternity in this world. And it's really awesome to be here today talking to you and having the chance. So thank you again. So as Gary mentioned, we're going to be talking today about PrivateGPT. I'm going to cover the origin of the idea, how we have been evolving, the status of the project nowadays, because it has changed a lot, as well as a demo. And then Ivan will take the second half to focus on use cases, taking a look at how we have leveraged LlamaIndex and how LlamaIndex is powering PrivateGPT, as well as covering some deployment details and for sure the future of PrivateGPT. So let's go into that. And by the way, I'm Daniel Gallego-Vico, for the one that you don't know me. I will be your first host for a while. Cool. So PrivateGPT, what is the original idea of PrivateGPT? So basically, PrivateGPT was launched initially May 2nd this year, but let's go a little bit behind that. If you think about when ChatGPT was launched, and you think about the first months of this year, I was in Amazon. Ivan was in a startup, a CTO. And we were finding different problems. For example, in my case, in Amazon, ChatGPT was completely forbidden to be used. But in other companies, the use of ChatGPT was risky because people was basically dropping internal data in ChatGPT to summarize content, to ask to specific chunks of text that they copy and paste into the ChatGPT interface. So that was a complete risk. And the idea of PrivateGPT, it's basically to prove that you can secure your data 100% by running everything local without having to expose your data to any third parties, OpenAI or anyone else, Anthropic with Claude or Bard, Google, whatever. So the original idea of ChatGPT was, PrivateGPT was more proof of concept of showing like this was possible. So basically the first PrivateGPT put together a lot of existing pieces in order to demonstrate that this was a reality. And the first version basically was able to allow customers or users in this case, because it wasn't a product, to talk to your documents in a fully private way, because everything was executing locally in your laptop by leveraging your GPU or CPU with no internet connection and using the LLM or the embedding model at your choice, basically depending on your capacity to execute this. First version was pretty minimal, I would say, from a user perspective. It was just a console interaction, kind of a chat-based. So as you can see, this was the thing. And since that point on, we have been evolving quite a lot. As Jerry was mentioning before, we have just reached 44 stars. You can see the evolution. Big thanks in capital letters to the community, because this it was impossible without you guys. It has had a lot of traction. I guess that this is a necessity. The factor of having privacy around your data when interacting with LLM was something that was missed in the space, and PrivateGPT brought that to the community and to the discussion. We have two versions. We call the primordial version to the first version that we launched in May, that was evolved through the subsequent months. But in October, we released a new version completely created from kind of scratch and with a completely new philosophy. And this is the one that we are going to be reviewing today. So what is actually the fuel allowing us to reach this point? The community, guys. Again, perfect synergy between the team, Ivan, Pablo, and myself. but especially more than 40 contributors that have been helping us on a daily basis, not only in the repository with code, but also in the Discord. As of today, we are almost about to reach 1,000 collaborators. And we have people that is every day helping us to keep this project alive, to grow this project, to make this project better. So again, thank you to the community. I have put a few names, the ones that have been busier helping us, but you guys, you are a lot of helping us. So big thanks to all of you. And as I was saying, if we focus on the project as of today, what is PrivateGPT as of today? PrivateGPT as of today is an API that provides a set of primitives that allows you to build GenAI apps with contextual information and privacy as the core functions or the core drivers. We have done in purpose an extension of the OpenAI API standard for the sake of allowing you guys to basically exchange without any broken feature. You can, if you have an application that is working on OpenAI on top of OpenAI API, and you migrate to PrivateGPT, it's gonna work. And basically, by doing so, you are gonna have all the privacy features and the contextual features that we have included on top of the OpenAI API. We will be talking more about that actually in the next part in the demo. I will be going into more details. But just to give you a high level of how the API is the API is designed, we have the high level API, which is basically a ready-to-use RAG pipeline. It's providing all the ingestion related functions, but it's abstracting them. So basically, you don't need to worry about managing the parsing, the splitting of the document in pages, all the metadata generated, all the storage in the vector databases, etc. All of that is taken care by PrivateGPT. Of course, you can go and use these primitives and create your own customizations if you want. And then we have the completions for chat and regular completions. And again, we are starting all the context retrieval, the prompt engineering, the response generation. Of course, PrivateGPT is a project for technical people, but we wanted to abstract as much as possible for those that don't want to dive deep too much. The second part of the API is the low-level API, what we call the low-level API, and it's the one that is going to allow you to create your own RAG pipeline. And this is the one that is exposing the embedding generation based on a piece of text and also the contextual chunks. And by doing that, you can imagine a lot of use cases. And Ivan and myself, we will be touching some examples through the presentation. Another thing that is important for this new version of the project is that we have put a lot of effort from the engineering software point of view. We have designed the project with a lot of concepts in mind that goes from dependency injection to testing to ensure that this project is solid, that is maintainable, that is scalable. And this is something that we have done since day one. But in order to stop talking so much and start showing more, I'm gonna move to a small demo in which I'm gonna show you how the current version of PrivateGPT works. And in order to do so, we are gonna leverage the Gradio UI client that we have created, which is an easy one and a really straightforward to use. So give me 1 second just to change. So I guess that you can see the PrivateGPT Gradio client. It's in dark mode because basically we configure the thing to adapt to your system preferences. And as you can see, it's pretty straightforward to use. You have the typical chat interface with the retry and do buttons for managing the kind of prompt that you are sending. The clear button to remove all the contextual information that you have generated so far in the chat. And then we have 3 modes, and this is where the thing starts to be interesting. So first of all is the LLM chat, and the LLM chat is the regular communication with the knowledge base of the LLM. In this case, we are using Mistral 7B. So if I ask, for example, who is Thanos, which by the way, I'm a comic book lover, you can see by my background. This is something that was pretty easy for the LLM to answer. I'm glad actually that he mentioned Jim Sterling, a really good comic book creator. So this is nothing new. We are basically using the knowledge base. But the interesting thing starts when we move to the query docs mode. And in order to do that, I'm gonna upload a document. So let me pick this book, Talking to Humans, which by the way, if you don't know the book, it's a really good book. It's about what should be the journey if you are creating a product from scratch with a lean perspective. And this book is reviewing all the stages, how to drive customer discovery, etc. So really good book. I have already told you what the book is about, but let's see if the model is capable of saying so. What this book is about. So now what we are using behind the curtains is the completions chat with the context information to set to true. So basically the LLM is using all the contextual information, which in this case it's created because of all the information derived from the book. And as you can see, it has provided a correct answer. The book is a qualitative research, has focused on primary customer development for entrepreneurs, blah, blah, blah. We can follow up and we can extend the contextual information of our RAG by not only considering the book or the document that we have uploaded, but also the context that we are generating through the conversation. So after reading this, I can maybe say, can you tell me more about customer discovery tactics? And here, it's not only taking into account all the information and the contextual data generated because of the book and all the chunks that we have created, but also is taking into account all the information that has been generated before in the chat. And this is the difference between the completions and the completions chat API that we will be seeing later. So in this case, as you can see, it's basically exploring the book and giving me the answers. An interesting thing that we have also done for the sake of improving or enhancing the OpenAI API is that apart from the contextual information included in the request, we have a sources attribute that when you use it, it allows the LLM to provide the customer what are the sources that you have used in order to provide this information. And you can see here that we are providing those sources. So this is, I would say, this is a basic example for sure, but you can think about all the use cases that you can build on top of that. Last but not least, from the UI part, we have a searching docs feature, and the searching docs is basically leveraging the power of the semantic search by leveraging the vector database. We are right now using Quadrant by default, which, by the way, if anyone from Quadrant is here, thank you guys for the support. We have created a partnership recently with them, so really happy for that. And what we are doing here is basically we are going to look by similarity just using the embedding models. So no LLM involved. So you will see that the answer is almost immediate. So if I look, for example, for the acronym MVP, which is something that in the book is mentioned several times, you could see that we are showing where we can find this acronym and what it's about, that section of the book. So this is an interesting way of going directly and in a really immediate way to extract information to create something on top of PrivateGPT. So this is kind of everything that you can do with the client. Of course, you can think about using a lot of documents together and so on. But if we go a little bit deeper and we go to the API, this is all the API documentation. So let's go directly to the playground. And we have here the ingestions, contextual completions, context chunks, and embeddings APIs. And we have all the primitives that I was mentioning before. So let's just start, for example, with the completions one. And we have we can play around here in this playground, which is something that is going to allow us to understand a little bit better in detail how this works behind the curtain. So the first thing is that if we execute our completions API with a question, how do you fry an egg, without including sources and without including the use context that I mentioned before, the interesting thing here, or the expectation, is that the LLM is going to answer using the knowledge base. So the knowledge base, as you can see, has the information about how to fry an egg. Pretty basic, so nothing really surprised. But the interesting thing here is if I say use context true, now we are going to ask the system to use the document that we have uploaded. And the document that we have uploaded is not about cooking. So as you can see, the LLM is not able to answer this. Okay. So if instead of that, we activate also the sources and we ask, instead of how do you fry an egg, how do you interview a customer, for example, and we execute this. Now, the LLM is taking into account not only the context that we have provided, but also the intention of the user to know more about the sources from which the question, the answer is going to be generated. So in this case, we can see that we have not only the content of the answer, but also we have all the sources that that the system has used in order to generate this answer. So here we have several chunks, each of them with a similarity score calculated, and each of them related to a document ID that we can play around. And about the documents ID, I want to play around a little bit with this. And if we go to the ingest list API, what we can do here is to execute this API in order to list all the documents IDs that we have created when ingesting the document. So this book is around 80 pages. I'm talking out of my memory, but basically what we are doing right now is that splitting the book page by page, and each page is gonna have its own document ID. So if you can think about the options that is giving you as a developer, you can go and play around by picking one of these document IDs and ask specific questions that are gonna be contextualized to that specific document ID, to that specific chunk of the document. So for example, if I pick this one and I go to the chunks API, which is down here. And we try out, we change this default document ID, and instead of Q3 sales, we ask for topics around customer and product, for example, and we execute this. What we can see is that the system has, by leveraging again the similarity and the vector database and the embeddings that we have stored, it's basically retrieving all the chunks in that document ID by similarity and giving you the actual chunk and also the information previous and next. And why are we doing so? Basically because we are saying we want 2 pieces of information that are extra apart from the chunk itself. But we can configure this, and depending on your use case, the idea here is to give you guys an idea of everything that you can do. You can limit the number of chunks to a smaller subset or to a bigger subset, and you can also play with several docs IDs instead of only one, because at the end of the day, this is an array. So you can play and fully customize this. And this is at the end the idea of PrivateGPT, that we have provided a basic RAG, which is completely focused on privacy of your data, but you can play around, you can build your own things. And that's something that Ivan is gonna go into further detail. So this is my part of the talk. Thank you for listening and for drawing in the screen. Yeah, the floor is yours, Ivan.
Daniel, this is great. I figured I'd just ask like 2 or 3 questions because there's been a few floating in already, and just to get a few out of these. So the first question, the first 2 questions is basically, what is the compute available for this application, and what's kind of like the hardware requirements required to actually run PrivateGPT locally?
That's a good question. So basically, the most important answer is that we are using Llama CPP, sorry, behind the curtains. So basically, you need a GPU to do that. If you try to execute this on top of a CPU, this is gonna be challenging. It can be done, but the performance is not gonna be the one that you would like to work with. But if you have a GPU, it's completely doable. Of course, I totally recommend to use small models. That's why we are using Mistral. And regarding the kind of hardware, well, I would say that, for example, the one that I'm using right now, it's one of the new MacBook Pros, the M3s. So it's quite powerful. So it's going pretty well. But we have been using in previous iterations when we started with the project, MacBooks from 3 years ago that were completely able to execute this kind of task in a matter of seconds, so or within 1 minute. Of course, I would say also that it depends on your use case. If you want to run PrivateGPT with contextual information that is derived from tons of documents, that's going to take more time because you will need to to deal with more data. And if, for example, if you need to ingest a document that is super big, it's also going to take more time. But that will be more or less the different data that you can take into account. It's completely doable with a new laptop that has a good GPU, but not a gamer GPU. It can be done.
Great. And then next question before passing it to Ivan is, So given the sources which you showed, does it kind of leverage and link to multiple documents, or would you be able to talk a little bit about how that works?
Yeah, so basically, the idea here is depending on what you ask, it will try to leverage several sources, and these sources could be from one or several documents. So at the end of the day, the moment that we split our documents in several doc IDs, several pages, the system is going to take into account all of them at the same time, not only one document, not document by document. Because if we go back, for example, in the UI, this is pretty easy to see. So when we query docs, we don't say I want to talk to this document. We are not selecting a specific document. So when you say query docs, you are asking the whole contextual database that you have. So any amount of documents that you have are going to be split into chunks, and you're going to consider all of them.
Sweet. Thank you.
Cool, good question. Awesome. So I'm going to stop sharing. Ivan, you take the lead.
Cool. Thank you, Danny. Okay, let me share my screen. Cool. All right. Actually, I think part of the questions, I was taking a look at the chat, and I think we're going to be answering part of some of the questions that you were asking in this next section. So what we're going to be doing is we're going to get into a little bit more of details, like on how this works and the different setups that you can configure using PrivateGPT to cover different use cases. So the first thing is So let's start with the use cases, because Danny didn't mention it, but we are both product people. So what we like is building products. We love technology, but it is for the sake of building products and solving problems. So we always think from the user perspective. And here are 4 very different use cases that they could all use PrivateGPT. So let's go through them. For example, in the first one, I'm buying a house. I have a ton of documentation, back and forth with the bank, financial statements, etc. I want the model to help me make sense out of them, but those documents are super private. I don't want them to leave my computer. So for that use case, you could just go with a fully local PrivateGPT setup, like the one that is the one that most people is using. So you basically download PrivateGPT and you get it installed. You download Mistral 7 billion parameters model. You start working with the Gradio UI. You don't need a fancy client built by yourself. And then you start asking questions. You basically ingest documents and start asking questions, like following like kind of the demo that Danny shared. There is a small goodie that you can be using. It is this bulk ingestion that there is a script in the project that you can use. You can point it to a folder in your local system, and it will monitor for new documents and ingest them. So you would be good to go with that. But let's look at different use cases. So imagine I'm a junior developer and I need help coding. I don't have a big issue with privacy, actually, but I just don't want to spend money on this. And I don't always have internet connection. So I need a local setup again. You could be using PrivateGPT with the local setup again, and probably Gradio UI would be just good for you. The thing that you would do in this case is instead of using the default Mistral 7 billion parameters model, you would probably choose a model that is a specialist fine-tuned on code generation in this case. For example, this Mistral Orca. You wouldn't need to ingest any documents in this case. So you wouldn't care about the vector store or the embeddings model at all. So you see, it is a very different use case, both using local setups. Let's move to 2 business use cases. So the first one is my company colleagues struggle to find in which document is certain information. They don't want the LLM to create like a description or a summary out of the information. They just want to know in which document is the information, because they have a ton of documents. We are a small IT team. Our documents are private, and we need this to be fast. So in this case, you could be using what Danny showed, like the chunks API. So you could be deploying PrivateGPT in your company server and use the chunks API. The good thing about this is that you don't need an LLM for this. If you just need to ingest a bunch of documents and then run a semantic query, a semantic search on them using a vector store, there is no LLM involved. And out of the sudden, you don't need a GPU in your server. So running this small embeddings model on a CPU doesn't require any resources. Like it is a normal web server, can run it. So you could be deploying PrivateGPT in your web server, running locally there the embeddings model, and you could build enterprise search application with PrivateGPT. And the last one is probably the most powerful setup. So I'm part of a company, I'm part of the development team. We want to build a chatbot that is for internal use because we're onboarding a lot of people and we want the chatbot to know the basics about the company and to answer questions to these new people. So we have a team, we're using AWS, for example, for our infrastructure. Okay, how would we use PrivateGPT? So you can use PrivateGPT by deploying it to AWS. And in this case, what would make sense is that you implement your own client, your own chatbot, using the completions API, most probably. I wouldn't host the Mistral 7B, for example, in the same machine where PrivateGPT is running, because PrivateGPT, at the end of the day, is an API, is a fast API. So I would probably be using AWS SageMaker to provide the LLM. You can just connect it to PrivateGPT. I'm going to show you how in a minute. The same for the embeddings. So you can connect PrivateGPT to a service where the embeddings model is. So you don't have to worry about deploying PrivateGPT in a very powerful machine. It can be a very simple machine just connected to SageMaker in this case. And for the vector store, you would be, if you have a lot of documents and you really need a performant chatbot, you would be using probably Quadrant, as it is a great vector database that is super fast when you have a lot of data. And you could be using a hosted version of Quadrant in your AWS. So it is still fully private. Your data is not leaving your AWS private cloud. So as you can see, these four use cases are completely private, are all using PrivateGPT, but are completely different setups and cover very different use cases, from personal use case to business use cases. So how does it work? I'm going to get into a little bit of detail. This is the most technical slide of the presentation, but I know many of you guys are developers. So something we wanted when we built the new version of PrivateGPT is that it was very easy to modify, to customize, beyond choosing the LLM, like changing it completely. Because at the end of the day, when you have your own use case, you need to fine-tune, especially the RAG implementation. So I'm going to tell you how PrivateGPT is architectured. So in case you need to modify it, you know where to go and how to do it. So the architecture of PrivateGPT is super simple. And part of it is thanks to how LlamaIndex is architected. I get there in a minute. So basically, PrivateGPT has three layers. You have the routers layer, which is implemented using Fast API, where the API endpoints are defined. Nothing new there, nothing fancy. There's not a lot of code. So it is just basically defining the endpoints. In case you need a new endpoint or you need to change one of the endpoints, you would just go to any of the classes named router, and you can just change it there. Then you have the services layer. The services layer is where the RAG is implemented, is where the business logic is. It makes use of LlamaIndex. If you download PrivateGPT, it just works because we put together a default RAG implementation. It is using contextual chat engine from LlamaIndex. It is using a sentence splitter from LlamaIndex. So we're using a RAG pipeline that is optimized for Q&A on your documents mostly. But imagine you need a different use case. You need something that can summarize your documents. So probably this default RAG pipeline is not for you. You need to change it. So if you want to change it, you just need to go to the service class and just change the implementation that is in there with your own RAG. The good thing about how this is implemented is that it is completely decoupled from the components, which is the third layer. So the components are the final pieces, the providers that power the RAG. So the providers are the LLM that you choose to use, the embeddings model, the vector store, and then what we call the node store, which is the index store, basically in LlamaIndex, which is for storing your index information and your documents information. So the good thing is that through using dependency injection, when you look at the services implementation, you won't see any reference to a specific LLM or to a specific vector store or embeddings model. And that gives you a lot of flexibility because you can change the whole RAG implementation without having to change or to think which LLM is going to fit here. Just so you know, if you want to change PrivateGPT source code, you can see on the right-hand side these layers that I told you about. So if you go to the chat completions, for example, you can see the chat router where the API is defined. You can see the chat service where the implementation of completions is defined, and then you have each of the components in each of the folders. And then again, if by default, PrivateGPT supports a set of LLMs. If for some reason you need to use a different LLM, you just need to go into the LLM component and implement a new block, and that's going to work with the rest of the application. That's the way it is architecture. So I know this was a little bit technical, but for you guys that want to change the code, change the actual functioning of PrivateGPT, you now know where to start. But most of the people just need to change the components. As we mentioned in the use cases, you most of the times just need to change the LLM that is being used, the embeddings model, the vector store, or where those components are living, are executing. And for that, you don't need to change any code at all. So what we did is we defined a way of setting those components. Those components can be configured completely using a YAML file, where you can define the LLM, the embeddings, vector store, node store. And just by having this YAML file, the dependency injection is going to make sure that those components are injected into every single service. So you don't need to change any other code in the application. We can do that thanks to how LlamaIndex is architectured. And that's why we chose to work with LlamaIndex. So LlamaIndex has a very nice set of abstractions that we're using heavily in the services implementation. So you will find there's an abstraction for the LLMs, there's an abstraction for the embeddings, there's an abstraction for the vector store, for the storage. So those are super powerful abstract classes that you can just use throughout your code without coupling your code to any implementation. And that's basically what we do. It's a very good software engineering practice, and we wanted to bring it to PrivateGPT. The result is that you can write a simple YAML file, like the one you see on the right, where you make PrivateGPT work for your use case. If you remember the different use cases, this is exactly what you can configure. So for example, in this case, we are running the LLM using SageMaker. So we are connecting to AWS SageMaker through this endpoint that we are defining there in LLM endpoint name. We chose to run the embeddings locally. So we are running the embeddings in the same machine where PrivateGPT is running. And in this case, we are choosing the embeddings model. And we're using Quadrant as the vector store in a local way again. So you can see the path is defined there. And that means that Quadrant is going to be running in what they call Quadrant local, which is using under the hood and SQLite using the disk to store the data. So you could change all of this, like you could make Quadrant connect to a Quadrant cloud, for example, or you could connect to a remote embeddings model, or you could make the LLM run locally. You can change everything just by setting the YAMLs file. You can see all of this explained in the documentation. I just wanted to share it with you. So that's the technical part I wanted to cover. I hope it was helpful. And if you have any questions, just don't hesitate to ask. Also to join the Discord, and we can get into more details. So taking a step back and talking about the future. So what is in the future in the roadmap of PrivateGPT? So you can see there's a lot of exciting stuff there. But I wanted to focus on what is driving our roadmap. And there is two main drivers. The first driver of our roadmap is the community itself. So as Danny mentioned, there's already almost 1,000 people in the Discord. It is super, super active. So there is people asking for help for setups, and there is also people contributing continuously. So much that we just opened a public board where you can see all the tickets moving around. People are assigning tickets to themselves, and everyone is collaborating so we are basically building in public. So that's the first driver of the roadmap. The second one is that we are so the team is also working. Our team is also working on a commercial B2B SaaS product. Does it mean that PrivateGPT is going to become commercial? No. So PrivateGPT is going to remain open source forever because we truly believe in the power of open source. But the best way to maintain an open source product is to actually use it in production. And that's what we're doing. We're building a B2B SaaS product that is not for technical people. It's actually for end users. That is part of the stack is PrivateGPT. So we're using PrivateGPT for our commercial product. That means that every time we need a new feature for our commercial product, we build it into PrivateGPT, so the whole community takes advantage of it. And we think this is a very, very honest and very healthy way of maintaining the open source project. I wanted to finish with this basically thanks slide where we highlight the partners that we have. So Quadrant, as Danny mentioned, is working with us to get the best performance on the vector database front. LlamaIndex is amazing. Like the way it is architectured through those abstractions and then all those different implementations make us go really fast on implementing PrivateGPT while keeping good engineering practices. And we're also like sharing tips and like the two teams are working together, which is amazing. And then the guys from Fern, they provide access to their paid service for free forever to PrivateGPT, and they're powering our docs, which are amazing. Take a look. And then we're working with them to provide also SDKs, so you can build client applications using PrivateGPT on TypeScript, Python, and different languages. It is something that we're going to be releasing very soon. Apart from that, obviously, Fast API is amazing. We worked a lot with LangChain, especially in the initial version of PrivateGPT. GPT4All, LlamaCPP, ChromaDB is also an amazing database to get you started. Sentence transformers. So yeah, basically, these are all open source projects, and I think the open source AI community is incredible, is thriving, and it is a pleasure to be part of it. I would say that's it. I hope we left some time for questions. And anyway, we are happy to have you in our Discord, where we are, again, super active, trying to help everyone that is around.
Great. Daniel and Ivan, thanks so much for the presentation. This was great. I personally have a lot of questions, but I just want to make sure we get through some of the questions in the chat as well. I think one question that's pretty top of mind for some folks in the audience is, so this user asks, I am researching PrivateGPT in an enterprise environment, and one of the biggest challenges is document ingestion and data quality. Do you happen to have guidance in how you do data ingestion as well as just data preparation in general?
Yeah, that's a good point. I think so. The way we are approaching the project is PrivateGPT, as it is, like with its default implementation, serves quite some use cases, like the ones that we saw in the use case slide for those personal use cases. But when you want to take it to your company, I think you need to research a little bit and understand what is going on under the hood. That's why we made it in a way that you can bring your own RAG. Basically, that's the idea. Like, understand what you're doing, bring your own ingestion pipeline, bring your own RAG. Having said that, what I mean is that we're not going to be, so we are working actively on providing a faster ingestion. For example, this is Louis, one of our contributors, is putting a lot of effort on that and with amazing results. but we're not going to be giving a solution that fits all. Like depending on your use case, you need a data preparation pipeline and then a different ingestion strategy. We are using by default sentence splitter, which we think works very well in many general cases. But for different type of documents, you need different strategies. So happy to discuss different specifics, but it's not going to be covered by default. So PrivateGPT is not going to be the magic RAG implementation for all use cases. That's what I wanted to yeah.
Actually, if I can cue in, just to highlight one thing that Ivan mentioned before, PrivateGPT at the end is not a product. It's a framework, an API that allows you to build products. So at the end of the day, the gap from technology or the API to the customer, you need to fill this gap. And that's something that PrivateGPT by itself is not going to provide because it's impossible by definition to cover all the products. But actually, that's what we are going to be doing in our B2B product. That we are going to take explicit decisions. We are going to be opinionated, and we're going to decide to do A, B, and C in order to fill the gap and provide something to end users. And that's something that at the end of the day, when you pick an open source project, usually it's not as easy as, deploy and use. So it's an active work that we all will need to do, which I think it's part of the interesting thing of working on this kind of technology.
Another question from the audience is, like in terms of the sets of documents that you ingest, I think you ingest like PDFs and other text documents. How do you think about ingesting CSVs or processing some stuff that's more tabular?
Again, I think kind of the same answer applies. I know there's people using CSVs. Specifically, there's some people that is changing a little bit the ingestion pipeline for that. It basically it should work. I think you probably, Jerry, have a better, because I know you've been playing with it with CSVs quite a lot. So you probably know what type of pipeline works best. But you can basically connect this specific pipeline to PrivateGPT. The default one is the best one for CSVs. Probably not, but it works in most of the cases. I know because there's some people using it for that.
I think if you want to do more tabular data, and this is more just like ideas for the future, you might want to think about basically like compiling to a query language like SQL or Pandas. I think that's typically how you interact with pure structured data. I think the chunking strategy for CSVs doesn't really work as well unless the CSV by like just inherently contains a ton of text data. So I think typically when people process very heavily tabular data, you probably a lot of times you get better results by just doing like something like text to SQL, basically.
Yeah, we have been playing with something like that, but just small, proof of concepts. So you totally are way beyond us.
Nice. What like maybe this is one of my questions. As you've been playing around with these models, obviously the local models themselves have improved quite a bit since when PrivateGPT started. When you started, I think I actually forgot the specific model that you were using. But now you're using like Mistral and like some of the fancier models. How have you seen these evolve, and how have you seen quality get better, and maybe more specifically in what areas, and how does that help you guys?
Yeah, I think it's incredible. Like because the first version of PrivateGPT was in May, and I remember putting it all together. And when it first worked, it was like magic in a sense because it worked, but it was so scrappy. Like the results were not good. Like actually, I was amazed that the community was embracing the project because the result was not good because of the quality of the local model. I remember we were using a GPT-4o model, one of the first ones, and at the time it was super scrappy. Like the results were not really good unless it was so clear for the LLM. Like there was no reasoning involved. It was like the answer is here, just repeat it to me, please. Now we've gone so far. Like Mistral 7B is amazing, and Zephyr is incredible. So, and it is running locally. It is running well. You just saw the live demo on Danny's machine. Like who needs ChatGPT? I would say, like, it's so good at the moment. And the good thing is that you can get Mistral and you can fine tune it to your use case. Then the options are Like, yeah, you can do so many things. Yeah, and for me, it's been like, for me, it feels like 5 years passed since May, to be honest, like from a technological evolution point of view.
Maybe related to, like, are you seeing any still like hallucinations from stuff like Mistral or Zephyr? And if so, you know, maybe one of the questions was basically like, also like when you ask a question, does it like start to hallucinate based on the context, or does it actually make use of the info? Or are you still kind of seeing that from current usage?
Yeah, but from our tests, and this is more on the, probably we're putting more effort on the commercial product, because you cannot offer hallucinations to final end users now. And but we're seeing that by using proper prompt engineering techniques internally, I'm not saying the user needs to prompt engineer, you can cut those hallucinations quite a lot. And I think people should move away from single shot type of flows with LLMs. You know, I think now that the LLMs are faster, and if you can run on a not on a local machine but on a server, you should start thinking, okay, maybe I need 2, 3, 4 interactions with the LLM to answer these questions. If you want to go one shot, you may get hallucinations, but you can double check with the LLM. So there's a little bit back and forth, and you get rid of that.
Actually, one thing that we have noticed by using models like Mistral is that when the context is small and maybe the question is not so good, as Ivan was saying, if you try a one shot, what we have seen as an improvement is that instead of hallucinating, it's basically saying you, I don't have enough context, which is way better than that giving you something that is false and you maybe believe it. So that's something that we have seen as an improvement in these few last months. But as Ivan was saying, at the end of the day, the key part here is not trying to solve everything at once, but doing some kind of iteration, which, by the way, the user doesn't have to notice it, or at least you need to hide that from the user. You will need to do a lot of things behind the curtains for the user to feel that this is still magic.
Got it. Makes sense. Another question that I was just like generally curious about is like, it seems like you're basically using the model itself in like a pretty like for synthesis, right? Like basically at the end part of the RAG pipeline. So as these models get better, especially for 7 billion like models, like they'll basically kind of like, you know, be better at reasoning over context and synthesizing an answer. Is your bet basically, or is your hope that basically you have like smaller and more general purpose models, or will you also make use of kind of more specialized models for different use cases? If that question kind of makes sense. Like basically, you know, there's this whole world where some people believe that as these, you know, in the future, like there will be a lot of like small specialized models for different use cases. I'm curious to get your thoughts on whether that would be useful, or if there's like another feature you'd be looking for.
Yep. Let me go in this one. That I would say that from my point of view, and again, this is kind of, we are kind of seeing the future. We'll see how this evolves. But I would say that in the future, this is gonna be more kind of a LLM as a service model, in which you pick the one that fits better your use case, instead of having a huge infinity window context in which you try to deal with everything in a generic way. And I'm not for sure putting aside all the AGI discussion, which is pretty interesting, but let's put that aside for a second. If you try to solve everything with the same model, and it's a really general one, in the long term, especially if you are thinking about a B2B environment, it's going to be really difficult to be right. For the, I mean, the use case of ChatGPT, it works because I would say that majority of users are general B2C users, which they need general information. But if you go to really specific domains, it's really difficult to keep the quality in a super general model. And of course, you can try to, you know, increase the context and so on, but that's kind of brute force to solve a problem. So I would say that in the future, taking into account that, you know, month by month is cheaper to train models, to fine tune them, etc. At some point in the future, the model is going to be, you have a set of LLMs, each of them trained for different purpose of your domain or several domains, and you pick the one that you want real time. And that's kind of my vision. Ivan, you can share.
Yeah, no, fully agree. Just to give you a sense of how much do we believe in that future. we applied some weeks ago to AWS SageMaker multi-model single instance machines with GPU, so you can run several models in the same machine. It's not publicly available, but we believe so much this is the future that we are started architecting for that in our B2B solution.
Sweet. Now, kind of asking a question from the audience, and I think this question is about if you happen to have like an architecture or solutions or thoughts around how do you think about like attacks, like model poisoning, like other related risks, or if you have thoughts around that.
That's a good one.
Yeah, no, I don't have an answer. We just need to be like, part of being like a native AI startup is to keep on studying every single day. I think we probably spend 30-40% of our time just keeping up with the ecosystem. I think that's fine. We just need to address for that, but I think it's fine. You cannot be building software like 8 hours a day. You're basically researching and reading papers and keeping up to date 4 hours a day, and that's just fine. So yeah, we are covering the known attacks at the moment. We are vulnerable to the not known attacks as everyone else.
Nice. Yeah, that makes a lot of sense. Another question that has to do with costs. If you were to like self-host PrivateGPT, how would you think about costs versus like say using OpenAI API?
I think so. Again, maybe we are biased by the way we are architecting our solution, because we are still, as it makes sense, we are still very focused on the private privacy private alternative to AI providers, and so we are architecting everything to be running within a private cloud. So we're basically dealing with costs from Google machines or AWS. And we are still running like tests on how much volume you can run against one of those machines. But having said that, if you're, again, it has to do with the previous question. So if you are good to go with 7 billion parameters to do most of the to perform most of the use cases that you need to, then you can run on a slightly smaller machine that is costing us, for example, at the moment, like I don't know, like $40 a day. It depends on how many users can you serve with that, but I think it can be more cost effective than just trying to build a wrapper around OpenAI. Actually, I think I received an email this morning that I don't know, I have to research a little bit more, but I think one of the models hosted by in SageMaker is doubling the cost. So you need to be very careful about the cost. So costs should be going down, but at the same time, I think every LLM provider is kind of competing in cost. And some of them are kind of taking a step back and saying, hey, we cannot run that cheap. We need to raise costs a little bit. And this is happening already. So yeah, you need to be careful. So I think small models is the way to go again.
Also, there is a concept which is basically, I mean, a general concept for engineering, regardless of the domain, which is don't design for the peak hour. So basically, you need to be, as Ivan was mentioning, you shouldn't design for really isolated use cases in which you have a lot of traffic, a lot of requests. You should design for the average mode, because otherwise you're going to kill yourself, because let's not lie to anyone, this is expensive. So you need to be very careful, because otherwise you can die by success because of the amount of traffic that you're doing.
Again, to Danny's point, not everything needs to be immediate. Not every interaction needs to be immediate. And again, we're taking this from the user to the technology and not the other way around. And when we talk to users, we find that they don't have this hurry. Like they can just ask for this and then wait, and that's just fine. No, and so out of the sudden, it is not a chat anymore, what you're building. No, and that gives you space to, as Danny mentioned, to design not for the peak, but to design a little bit smarter your cost structure.
Yep.
Sweet. Great. Thanks for the answers. I have more questions, but I figured given that we're at time, we could probably end it here. And if you guys have any questions, please feel free to join the PrivateGPT Discord, which is linked right here. You can also hop on the LlamaIndex Discord for any further discussions. And we'll, of course, have the recording up on YouTube as well, and we can continue chatting there. Great. Thank you so much. This is a wonderful presentation, Ivan and Daniel. And thanks everyone for tuning in, and we'll see you guys next time.
Thank you, guys. Thank you for your joining. Bye-bye.